Hey everyone, welcome to the ChainLinkGod podcast, where we break down the information asymmetry on all things blockchains, oracles, and smart contracts. Today, we're going to be doing a little bit of a deep dive into off-chain computation, and in particular, trust minimized off-chain computation that can be performed by oracles to complement the capabilities of blockchains. To help me today, I have with me the crypto oracle. How are you doing today?
Yeah, doing good. It's been a while, so glad to be back on the podcast.
Yeah, it's always good to have your knowledge on this podcast. So I think to start things off, could you give a little bit of a brief recap on the functionality and the roles of oracles in the blockchain ecosystem?
Sure. So obviously, as most people listening to this podcast, probably familiar with oracles, but maybe we'll do just a really quick recap before we get into the main topic. So obviously, oracles are most commonly recognized today for their ability to go fetch data from outside the blockchain. People call this the real world, even though everything's kind of the real world. They validate its integrity and correctness, which means validate where did it come from and how correct it is. That's where you can use various aggregation techniques, and then it's going to deliver that result onto the blockchain where the smart contract can then consume it. And this capability, data fetching, whatever you want to call it, it's outlined in the Chainlink 1.0 white paper in 2017, and effectively solves the oracle problem in any type of practical sense. What we mean by oracle problem is simply, the blockchain by itself, blockchains can't go reach out and get external data. That's the original idea of the oracle problem, and I would say that's, we see that pretty prevalent today in a lot of the initial use cases for smart contracts. For example, data oracles today fetch financial market data, which many DeFi applications need. For example, lending markets need asset prices in order to issue loans or to liquidate loans. We see this in a lot of parametric insurance contracts. For example, weather data for crop insurance, flight data for flight insurance. So I would say data oracles have seeded a lot of the initial use cases for smart contract economy. I mean, not every use case uses an oracle, but a lot of them. And I think that's only going to increase more and more. I would say you're going to see upwards 80-90% of use cases that are probably going to use oracles. And, this is why you see Chainlink price feeds, which, have fueled a lot of DeFi's growth. They now secure, I think it's around $76 billion in on-chain value as of today. So that means assets on chain that are held by smart contracts in these different DeFi protocols, and the oracle directly triggers how those assets are moved. So that's the basic recap. I think our audience is fairly familiar with that. Do you have anything else to add before we move on?
I'd say that's the main thing. People usually think of oracles serving as the inputs to smart contracts that effectively tell them this event happened. Now you can do some predetermined function based upon what happens in the external off-chain real world, whatever you want to call it, outside the blockchain. So it's like the IO of smart contracts, I think, is how a lot of people see oracles today.
Yeah, and that input basically directly determines the output. That's what makes it so important. We see this basic idea of data delivery or fetching and then delivery, but really this is kind of the tip of the iceberg when you think about what oracles can actually, the much more expanded capabilities of oracles, and particularly for generalized oracle networks. And generalized in the sense that the oracle protocol is not designed for one specific chain. It's not designed in one specific way. And so you can think of it, and it's not one network either. So for example, Chainlink is chain agnostic. It can run natively on any chain without a dependency on another chain. It's also heterogeneous. Hope I said that word right. I always feel like I'm saying that word wrong, which means that you could have many oracle networks running at the same time in parallel without any dependencies on one another. And also the oracle network itself is customizable. So I could have 5 nodes on one, and the other one I could have 100 nodes. And these ones could be set to this aggregation pattern. And so it's totally customizable. Particularly in generalized oracle networks, because I say generalized because non-generalized do not necessarily have these type of properties. They're kind of built in one specific way to do one type of service. Whereas a generalized one, you could build them all to whatever parameters you want. And so you could basically cover any use case. And so for generalized Oracle networks, I think a much better definition of oracles is that they can provide smart contracts with any service or functionality that they cannot obtain on their native blockchain. And this could be due to several reasons. For example, cost, it's too expensive to do on chain. Technical reasons, whether that's privacy, whether that's scalability or various other challenges on the native chain. And this also could be from legal constraints. For example, certain laws have, where you can only do certain computations to a specific region, or maybe you can only have certain counterparties do your computation. So in a generalized Oracle network, you could actually customize your network for those parameters. So, this is more for enterprises, but again, this could be a reason why you maybe couldn't use a blockchain for some form of computation. And the reason that oracles are designed for something like this is because they actually can perform a unique form of computation, which we refer to as trust minimized off-chain computation. And this is kind of like Oracle computation is a shorter form, but the kind of the more technical definition would be trust minimized off-chain computation. So you're reducing trust minimized, trustless, trusted. Those are kind of weird words, but the idea is that because of certain parameters that you've set in the Oracle network, it's less on trust and more kind of on mathematics. Like the probability is very high that it will perform the computation exactly as you had it. And you don't need to you don't have like a paper promise or whatever. You have more of a mathematical guarantee or probability guarantee due to the way it's designed. And the idea of trust minimized computation is to extend the capabilities of the smart contract beyond what it could achieve on its native blockchain, whether that's scalability, cost efficiency, fairness, different new functionalities like different types of automation, adding privacy and various other features. And so to kind of see the value of trust minimized computation, I think it's helpful to look at the various types of computation out there so it can be put into a broader perspective of where it sits between Web 2 computation and blockchain computation. So maybe you can kind of walk through these different types of computation so people can kind of see where it lies.
Right. Yeah. I think it's important to kind of see computation in terms of whether you need to trust or not is kind of existing on a spectrum. And when you kind of break down on what is a computation, it's effectively any kind of calculation that's defined by a predefined set of instructions. So you execute the first instruction, then the second, then the third, then the fourth, and continuously, and you give that an input and you get an output. So traditionally, computations have existed in many different forms. And, in the very beginning were manual computations done on the pen and paper, and then kind of moved on to more of analog computations. And then now the vast majority of computations that are performed are digital. So they take place on computers. And computations are really what drive a significant portion of our entire economy and society. The most traditional and the most well understood and what's kind of been used for computation for the past decades is what you can kind of sum up as more centralized or Web 2.0 computation. So this is computations that are performed in some centralized data center. So that could be operated by Google or by Facebook or by Apple or Amazon. Any kind of these these entities who provide the infrastructure to execute whatever computations that you need. And so having a centralized domain to perform execution allows for a significant degree of basically economies of scale. So that allows each individual computation to be extremely cheap, and you can perform any type of computation that you could realistically want. So when you have this centralized entity providing you basically computation as a service, it's extremely flexible. However, there are fundamental trade-offs when you have computation occurring within a centralized entity or within a centralized sphere. And effectively, that comes down to those computations are not very trustworthy. Whoever hosts the computation, whoever's performing those computation, effectively has unilateral control over those computations and the result. You basically have to trust that entity that they correctly perform those computations and they accurately relay the results of those computations to you. because oftentimes there really isn't a way to directly verify that a computation that was performed faithfully and accurately and on time. So this can generate extremely undesirable properties that are becoming more prevalent in existing kind of Web 2.0 services, whether that's in terms of censorship, where there's basically a single entity who can prevent you from accessing the computation or whatever services that are enabled by computation. The centralization can allow for downtime where nobody can access those computations and can put a lot of applications at risk. And I think the big ones really is effectively the gatekeeping and the rent extraction, where a single entity effectively has full control over any services that depend upon that computation. They can change the rules on you, they can prevent you from accessing it, and they can raise the costs over time as they have full access over what you want to do with your computations. And fundamentally, centralized computation in terms of all the existing Web 2.0 services are permissioned by design. And you're effectively asking them to be honest with what they do and trust that they're not going to screw you over for whatever monetary or political or societal reasons that they believe are the best route to take for them.
Yeah, I just wanted to add that just a way to like maybe visualize this for people. I think if you take a lot of companies, but the most obvious ones now are like social media. Say you have someone like Facebook. Whether they run in a cloud or they have their own data center, it doesn't really matter. But because they control the computation, they can they can censor you. They can kick you off the platform like that because they have that centralized point. You don't actually know how the algorithm runs. You don't know how content is ranked. You could do this with YouTube, with Google search engines. Like the computation is determining the algorithm, for example, and how things are ranked, how you see things in your feed, things like that. There's basically no transparency into how that works. And so no one, and that affects content creators and all these different, a lot of entities in terms of marketing for your search rank, things like that. And so because that's proprietary and that's, not transparent at all, that basically operates however they want. And that's okay when you're a smaller company, I think, perhaps. But the problem is that these entities become so large that they become almost like social goods at that point, or they become like the town square, or like Google search engine is like, I don't know, the library, the index of the world's information. And then when they become so large, you don't really know how that computation actually works. And also it gives them power when they become so large and people have voices that are not, in the mainstream consensus, then they can get, censored, they get deranked, or they can, there's lots of things that they can do. And so some of these problems really get magnified at scale. They don't seem they don't seem as big of a problem at a smaller scale, although they can be, or even like payment platforms and things like that. Like this is also where permissions come in place as well. Like, oh, well, you can't be a part of this kind of computational system if you don't abide by certain rules. So I think a lot of these problems get magnified as you go up in scale.
I think that's a good way of framing it. I think social media is kind of like a predominant example of that. I think computation, it's a bit of almost like an abstract term of like, basically like the computation is like the underlying substrate on which services can be built on top. And basically our existing web, the existing internet today and all the services on top, whether it's the apps you can download on your phone or whether it's the websites you visit, all of that in the back end is running based on centralized computation. And so when everything is built upon a substrate which can be censored and which can be controlled and which can be captured in many different ways or extract rent, then that's almost always at scale going to lead to a worse user experience. And historically, there hasn't really been much an alternative. If you want to build a service or an application or something, then realistically, it's always been hosted on centralized services because that's how you're able to bootstrap your services. But given all of these downsides, none of the services are able to basically be credibly neutral in that regard.
Yeah, just further than that, it's like the computation is like the engine that powers the system, and so you almost have, and you have to tap into that engine to reach a lot of people and for a lot of different, whether that's whether that's YouTube, whether that's Facebook, whether that's payment platforms, like all these become so dominant in society, like everyone uses them, that you have to be able to tap into that engine. And if one company owns that engine, it can, there's a lot of things that they can do. And then it gets very political. And this is just a problem as it scales. The governance, it's really hard for the companies, the governments, and they're getting political pressure and various types of pressures. And then, then they change the rules, like you said, and it can affect a lot of different types of groups.
Yeah, I think this is like it's easily apparent to many of the users because a lot of the people listening here are probably the end users themselves, and so they can see the harmful effects of censorship. It's also a harmful aspect for other independent developers who want to build services. If their only option to build scales to rely upon centralized services, then they're basically handing over control of their services to whatever computation platform they're on. So this is kind of the centralization, capture, and censorship of the centralized computation platforms effectively affects the entire web stack from developers to end users to basically society as a whole. And for the longest time, centralized computation platforms have been the only way to actually reach scale. But now we're seeing more of what's kind of sometimes referred to as Web3, but is more kind of focused on blockchain computation, kind of provides an alternative. So maybe this is something you can step into, how blockchain computation provides an alternative.
So obviously you just went over Web 2.0 computation, or centralized computation, however you want to frame it. And blockchain computation is kind of, I don't want to say the first, but I don't know, maybe one of the first real alternatives to Web 2.0 computation, at least in terms of digital computation. So blockchain computation, it leverages a decentralized network of nodes, which basically validate and perform computation that's responsible for moving assets or storing data on a ledger. So during blockchain computation, the nodes, they perform a couple pretty basic computations. For example, they're going to verify signatures on a transaction, basically authenticating that the person who's sending the transaction owns the assets to that account. They're going to verify balances, that the person has enough money in order to make that transaction. They're going to actually execute the transaction, and they're going to perform various, calculate various proofs in order to create new blocks, a proof of work, a proof of stake. And they're also going to execute historical blocks to basically check the work of other nodes on the network to make sure that their these new blocks that are added are valid. With these blockchains, you have a lot, I think most of the blockchain value is going is you have all these applications that are built on blockchains, which are, basically called smart contracts, and they're powered by this blockchain computation. And the features then that are afforded to these smart contract applications, as opposed to what we traditionally see in Web 2, is they're going to get a high degree of censorship resistance. The blockchain can be credibly neutral. It has no, stake really in seeing one or another outcome. You're going to get strong uptime. The blockchain is pretty much always available, and it's going to be permissionless and open by design. So anyone can tap into that engine and use that blockchain computation and get access to that blockchain computation. Anyone could build on top of it. And so this is kind of the idea of blockchain computation, the features that you get from it.
I think kind of putting in perspective, like what's the core differences in kind of blockchain-based computation. I think primarily it's effectively, we're moving from a model where a single entity controls the entire flow of computation to one where no single entity does, but rather it's entirely community driven, where the community defines what the rules of a blockchain is supposed to do. They help secure and validate this blockchain by being a single participant, where no single participant controls it, but they all contribute to the security of a network. And anyone is able to opt in and join a blockchain network, verify that what the blockchain is doing is actually following the rules set by the community. And if it's not following the rules, they have the option to basically fork and create their own version of the blockchain that follows their version of the rules. So you're opting into the rules that you want to participate in, and then you're actually helping ensure that those rules are actually being followed in, rather than Web 2, which is just trust based. So I think that's like one of the fundamental advantages, I think, here.
Yeah, basically moving from a unilateral control model to a consensus-based model, as well as a closed source proprietary model to an open source, open access model, as I think the general switch that's happening there. And so with this blockchain computation, obviously comes a lot of benefits that we've just described above, but there are limitations. For example, like highly decentralized blockchains, say Ethereum, is optimized for censorship resistance, but the throughput is slow. And so when you're really decentralized, you're usually going to be slower, and it's going to make computations more expensive and again, slower. And so you're going to have those limitations. We already see those in Ethereum today. And then you have higher throughput blockchains, the layer 2 networks. They're cheaper and faster, and they've gained some more popularity recently. But similarly, they're going to have computational limitations. For example, maybe they don't have built-in privacy. You're going to need various types of automation services. They might have problems with fair transaction ordering. And also, they're going to hit limits likely on their computational capacity as well. Because I don't think many people realize necessarily that these networks are also probably going to hit certain computational limits. And I think what happens is that when the transactions become cheaper, you just see more of them. Not, you could say spamming, but not. People make more and more transactions, and you hit block limits faster, even on these chains, and so you might hit certain limits even on those as well. And it's kind of a side tangent, but I think something people don't think about maybe as much.
Yeah, I'll step into that. I kind of want to set some context as well in terms of like, well, why do we need to have a super decentralized blockchain? Why can't we just tune up the parameters, make a blockchain super fast, and then we've solved this problem? But decentralization matters in a sense that it needs to have a low barrier of entry so that people can actually enter the network and perform the verification. Because if the barrier to entry is too high, where the throughput's really fast and transactions are cheap, to a certain degree, but now nobody can actually verify the network, and now you just have another trusted third party, and you're kind of back to the Web 2.0 model effectively. And so layer 2s try to optimize and use decentralized blockchains for settlement, do execution of smart contracts off chain, and then settle it back to the decentralized main chain. And that provides a higher ceiling of transactions, but ultimately there will always be a ceiling on transactions, where if you have more available space, then you kind of have what's called induced demand, where if you increase the width of a highway and now you have more lanes, well, now you have more cars to use those lanes, and then it gets filled back up, and now you're kind of back at the same problem. You have more transactions going through, but you're still going to reach a level of congestion. So I think ultimately for any blockchain to scale, they'll need to not only optimize their own parameters, but kind of scale horizontally, push things more off chain while still verifying what happens off chain on the blockchain. So having many different off chain computation solutions performing different calculations, then settling small proofs back on chain. So that way you're optimizing the usage of a highly decentralized blockchain, even as it becomes more congested, making the per transaction fee go down effectively. So there's kind of a lot of different nuances on how off-chain compute can kind of scale chains.
Yeah, and I think this becomes more important as you become larger. I mean, once you start settling, billions to trillions of dollars in value, that settlement layer and the security of it becomes increasingly important. And so, optimizing for security at that layer is going to be, I think, really important. And you're going to want a multi-layer, I think, scaling solution. But anyways, if blockchains are to basically accommodate mass adoption for smart contract based applications, which I think me and CLG both believe is the future, the computational layer is going to need to be enhanced. It's not all going to be done on layer 1. Even if you're a high throughput chain or L2, you're going to need additional enhancements, whether that's privacy and other types of features. And so smart contracts are going to need to offload certain parts of their computation off chain. And some smart contracts may use a lot of off-chain computation, some may use less. It's going to vary across chains, it's going to vary across dApps, but essentially you're going to have smart contracts do some of this computation off-chain and then deliver the results back on-chain. And centralized Web 2.0 computation, while you may see some of that, you may see smart contracts use them for some features, the security models are not going to line up, because once, for a lot of different parts of the contract, because you're basically going to then have a single point of failure where that central, that computation can directly determine the outputs of the smart contract. And so I think this is really where oracles and trust minimized computation come in as this way to scale off-chain for smart contracts while still upholding the security model that is the basis for the whole value proposition of the smart contract in the first place.
Yeah, I think effectively, when you want to extend the computational capabilities of blockchains, decentralized Oracle networks provide a very real, viable solution here, because it can perform computations on the behalf of smart contracts while still being anchored to the blockchain to maintain the key property of trust minimization. So oracles kind of sit in this nice range where oracles can perform computations that are at a higher speed, lower cost, and more feature richness than what blockchains can provide on their own, but are more trust minimized than Web 2.0 computations. So it kind of extends the capability of blockchains while maintaining the properties of the blockchains that people actually care about. So oracles can achieve this trust minimization using strategies that are particularly similar to blockchains in terms of having decentralization, so there isn't a single point of failure, having financial incentives to ensure correct computations are done and uptime, and methods of being able to actually directly verify on-chain that an off-chain computation is correct through different types of signatures and proofs. And so there's a different variety of different methods through which this can be done. This can be different forms of secure multi-party computation, where you kind of split up the computation across multiple entities that all generate a single output. You can have cryptographic proofs, or like zero knowledge proofs, where it's cryptographically proving to an on-chain contract that off-chain computations were correct. You can have different types of fraud proofs, where you retroactively prove a computation was incorrect. And there's even forms of, specifically in automation, where you can re-execute what happened off-chain on-chain when execution actually needs to happen, so you're able to fully verify it. So you have all these different security properties, these different ways you can verify off-chain computation directly in a manner that's cheaper and more efficient than just performing the computation directly on-chain at every possible moment that it needs to be done. So a lot of these different parameters and more can kind of be fine-tuned due to more of the heterogeneous nature of generalized Oracle networks, where users can define exactly the parameters used based on their trust assumptions and on their budget desire. So that could be different amounts of Oracle nodes performing computations, different levels of cryptoeconomic security in terms of financial exposure and even explicit staking. You can have different levels of privacy and hardware-based security, like trust execution environments, and any computations that rely on external data can have a different quality of nodes and data sources to fetch the data that computation relies upon. So oracles can perform a wide variety of computations that can be mixed and matched together in order to create applications that are more advanced than just smart contract code on-chain in isolation. So and kind of at its fullest scope, you can kind of think of generalized oracles in this regard as kind of being the full stack off-chain solution for smart contracts, where any service, any solution, any computation, any data that a smart contract requires can be provided by fully generalized Oracle. And this can effectively not only extend the capabilities of smart contracts and what they can do, but as we've kind of seen with layer 2 networks increasing the scalability, Oracle nodes can kind of directly bootstrap, contribute to powering these layer 2 off-chain networks as well. So it's kind of the full breadth in terms of what you can do in terms of services and in terms of depth of how scalable and the cost efficiency of those services. So there's a lot of different Oracle services that the in particular the Chainlink network provides today and will provide into the future. And I think this is something that you can step a little bit into.
Yeah, so this is, some people are familiar, but let's look at some of the types of Oracle computation, and particularly why the Oracle is suited to perform this type of computation. So for example, one, verifiable randomness. You see this with Chainlink VRF, where the Oracle nodes are basically a random number generator. So they generate a random number, but they do it in a way where users can prove that that random number was generated in a manner that's tamper-proof. And this is when you try to generate a random number on chain, you run into problems where the miners can manipulate the random number, so it's not secure in that regard. When you do it off chain, there's no transparency into whether that random number is truly random or someone didn't use that random number to their own advantage. So the Oracle computation is unique in that it can perform the computation cheaply off chain, but then it can prove what it did on chain was high integrity. And so you don't run into the same on-chain and off-chain problems that you had, whether that's with Web 2 or blockchain itself. So we have VRF. The next one, Chainlink Keepers. So with Keepers, it's essentially an automation solution. What does that mean? I think of it like this. Smart contracts are like a program that runs certain code, but that program is not going to run until you click start. And in order to click start on a blockchain, you basically need to issue an on-chain transaction. So keepers are designed to basically click that start button, but they can do it based on certain predefined conditions that the dApp sets. And that's valuable because you basically get to eliminate a bunch of unnecessary on-chain computations, or else you'd have to be constantly checking on-chain whether that certain condition was met, and that's going to be really expensive. Whereas instead, the Oracle can perform those computations off-chain. Like, for example, it's continually checking if a loan is under collateralized off-chain. And then once it's found it's under collateralized, then it can trigger the liquidation function. And then the smart contract can, verify it's under collateralized and liquidate it if it is. So this eliminates a lot of on-chain costs. Fair sequencing services, FSS. What this does is it basically takes in user transactions and then it orders them according to some notion of fairness, whether that's first in, first out, which is probably the most widely used one. You also have Deco, which is basically what it does is it generates zero knowledge proofs. So basically it tests to data that exists off chain. Say, for example, you want to verify if someone is of a certain age or they have a certain amount of money in their bank account. The Oracle network can basically log in with you to your bank account, check only the specific information that it needs with basically a yes or no answer. Is she above 18? Yes or no? And then it will basically relay that back on chain without revealing any of that data. And it's just a yes or no answer. And so again, it's doing something off chain and then proving it on chain. And then you also have CCIP, which is the cross-chain interoperability protocol. And obviously, when you're doing this, you're going to need Oracle networks to communicate between chains. And so you can't do this on chain by itself. You're going to need Oracle networks to read and write between different chains in order to move data and assets and commands between these various chains. So each one of these is very similar in that you're doing things off chain and then you're proving them on chain through various techniques. And then you're also using certain security features, whether that's decentralization, cryptographic signatures, zero knowledge proofs, or whatever, to bring this trust minimized guarantees that you want and then prove them on chain.
I think computation in the context of blockchains today, what we kind of see are very geared towards extending the capabilities of both the underlying blockchain and the smart contracts they can do themselves. But I think even here is kind of just the tip of the iceberg in terms of what computations that Oracles will actually end up doing in the long term.
Yeah, I kind of see this as part of a long-term trend that is really the ideal potential makeup for smart contracts in general, where, like we said before, the blockchain starts to act more as that settlement layer. And a lot of other people talked about it. It's a lot of it's just verifying proofs of what's happening off chain. And the Oracle networks kind of act as that computational layer because they can basically perform very similar to what Web 2 computations can do in terms of speed, in terms of feature richness, but they're designed in a very unique way where you can get these really strong security guarantees, very comparable to what you would want from a blockchain. And so this to me is like that scalable model where you can get that computational layer that you want, but you can retain those security guarantees that you want. And it really enhances every blockchain, and it really allows the blockchains to reach that scale that they would need to for mass adoption, because they're not the computational layer anymore, but they still provide that anchor, a security that you absolutely want, or else there's no point in smart contracts in the first place.
Yeah, I think you really hit the nail on the head there in terms of like blockchains today are trying to do everything. They're trying to store the data, they're trying to compute on the data, they're trying to generate consensus on everything. And I think ultimately, if blockchains end up being the base settlement layer, the most decentralized and the most censorship resistant, then I think oracles will end up filling up the layer of the execution layer. So anything that happens on layer 2 networks will use FSS for ordering, and then oracles to execute transactions and generate proofs. And that could be done at extremely high speeds. It can scale horizontally across many different L2 networks, all that are extended themselves through all these additional computation services, randomness, automation. But at the end of the day, are all settling on a highly decentralized blockchain network that may be feature limited, but has enough flexibility and programmability that it can verify these proofs of the computations that happened off chain at a much, much higher speed. So this modularization, as it's kind of commonly put, is how blockchains will scale. And I think our thesis here is that oracles are going to play an incredibly crucial layer at the execution layer to complement the consensus in the settlement layer.
I would go even further too, that I think oracles play a really strong filtering layer. Yeah, I guess you'd say filter or wrapper for Web 2 systems to be used by blockchains as well, in the sense that you can aggregate different Web 2.0 services, or you could basically, as Chainlink brings on staking and things like that, you could actually bring a staking mechanism to your off-chain service to bring a higher level of guarantee that service is going to be done in a certain way. Or maybe you can use, maybe even potentially start to use different types of trusted hardware within these off-chain systems, and they kind of become Oracle nodes that run trusted computation in their data centers or whatever, and then you can bridge those onto smart contracts, because they could be more trusted and they provide different guarantees. So I kind of see it as a bootstrapping layer, or kind of a wrapper on off-chain systems as well, that allow them, not just a wrapper and a gateway, a connector to kind of get them on par without changing those systems. You're just kind of like adding a layer on top of them that allow them to be trusted in these smart contracts as well.
I think it's part of the reason people are kind of don't fully grasp the power of oracles, just because there's a lot of different capabilities and different angles they can take. They can extend the computation, the scalability of chains. They can connect from external resources and bridge that on chain. And they can serve as a wrapper to basically introduce existing Web 2 services into a blockchain Web 3 ecosystem with either minimal changes or changes that make those existing services more secure, more reliable, more dependable. So oracles are kind of like the ultimate middleware layer, sitting between everything in the ecosystem, sitting between blockchains for interoperability, between blockchains and Web 2 services is like a gateway, and ultimately even between Web 2 services by just introducing additional security mechanisms that anchor to blockchains, but it's more of like Web 2 to Web 2 interaction, just at a more trust minimized sense. So it's like this multi-layered approach of connecting everything together in a more trust minimized manner. And so like when people still generally think of, oh, I know oracles, they're price feeds, it's like, saying the internet is just email. Like, okay, you're not like technically wrong, but it's not the full scope of things that oracles can and will achieve.
Yeah, I think it goes back to what you said earlier, and that's really what the full stack off-chain solution is. Like, it's not one service. Like, It's not just Oracle's connecting things. It's not just Oracle's maybe providing some of their own computations, but also, wrapping off-chain service, wrapping Web 2 systems and making them, more trustworthy as well. So there's really like three different components, probably even other components that, we'll see in the future that I can't even think of yet, but there's like three different components wrapped in there. And that's why I said every dApp, every chain, every off-chain system, Web 2 system, they're all going to use oracles in different ways. Like there's no one way to use it. That's why, like, a generalized Oracle design like Chainlink, you can really service any need. And that's why I think it could become a standard, and everyone can, and that standard becomes valuable too as more people use it. Then it becomes like a central reservoir for how all these systems are going to communicate, and it can be customized and whatever. So, I mean, I think that's really why we always say, Chainlink could become a standard. Like a non-generalized Oracle network could not be that.
Yeah, there's so many different angles here, and the reality is that hybrid smart contracts are going to rely upon oracles for all of these different capabilities, for computation, for data delivery, for bridging between chains, and for connecting Web 2 services together. And ultimately, this will, kind of think of oracles as like an enabler, pretty much. They're an enabling technology. They're not aiming to replace Web 2, and they're not aiming to replace blockchains. They're enabling interoperable ecosystem that's more trust minimized and more interconnected. And that will ultimately allow for more applications. And we already see that today with DeFi, but honestly, that's just a case study for what smart contracts will actually end up being used for at scale. So
to add on that, I think as we go further, there'll be a lot of opportunity to bootstrap like your own layer 2 network. So like, right now we have some like generalized L2 networks where like you have an L2 that's like generalized for a lot of different applications, but you could have kind of your own L2 for your own dApp. And I think you could use this, you could basically use Oracle nodes to bootstrap your own little mini L2. So it's like, I have our own dApp and we want it for a very specific purpose. And we can kind of bootstrap our own little mini L2. Like you could use, for example, you could use Arbitrum, and then you could use Chainlink nodes as your validator set for your Arbitrum kind of mini L2 solution. And I think there's going to be a lot of value, like enterprises could do this especially, but I think there's opportunity in a lot of different ways where you could create a custom L2 to your own parameters. This is it's still a bit early in this, but I think you'll start to see that because Arbitrum isn't one L2 chain. It's also kind of heterogeneous, and you could have lots of different Arbitrum L2s. Same with other L2 solutions, not just Arbitrum. But I think you're gonna see this more and more, as time goes on.
I think that it goes back to the thesis of everything at the execution layer will ultimately be oracles, and because Chainlink's the standard, ultimately be Chainlink oracles. Because you have this very generalized set of, I think of them as like off-chain agents that can do anything on behalf of contracts. And layer 2 networks are effectively smart contracts, is how they work. And so when you have this reliable set of nodes, you can bootstrap pretty much every single piece of off-chain infrastructure that you need for your dApp to exist. So I agree, it's very early days in that regard for this to come to fruition, but I think there's a lot of potential in terms of oracles. I think we set a lot of context here, and I think it would be interesting to dive more into layer 2s. I know that's something I've dived into a lot. I know that's something you've dived into a lot. So I think next podcast we could do more into layer 2s. But I think this was a pretty fruitful discussion. So I just want to say thanks for having this discussion. Do you have any last thoughts?
I would just say that if people want to read a little bit more about Oracle computation, there's a good article that was put out on the Chainlink blog. What is Oracle computation? I think it's a good read to kind of, get some more context, and even if you kind of get it, when you start to read it again, it sets a little bit deeper and you start to see it a little, crystallizes a little bit more in your mind. So I'd recommend people to give that a read.
Yeah, I would agree with that as well. That sets a lot of the context of how Chainlink works for off-chain computation today. And I think any developers wanting to build with Chainlink, definitely check out the documentation. I think it's not always technical in the weeds, but even for like end users, it sets a lot of context of how can Chainlink do off-chain computation today for me. So I just want to say thanks for everybody for listening, and just know that knowledge is power.